The Barde Weft senior design team, composed of Matthew Green, Lee Klein, Caleb Sallow, Cesar Valverde, and Josh Martinez, have been working to re examine and maximize performance of the Barde aramid fiber weaving machine. Barde is a company that manufactures and sells aramid fiber weaves for commercial and professional use. These aramid fiber weaves are primarily used in military armors, for personnel, and vehicles. The weaving process consists of one machine that injects a strand of fiber called the weft between a cross-hatched weave of strands called the warp. The machine is currently limited in speed by the weft scissor. Barde has asked the senior design team to come up with a solution to the scissor to allow for faster cutting speeds. The specifications Barde has requested for the modified scissor are increasing the current machine speed by 100 cuts per minute, fewer than 2 machine stops per day, proper integration into the current control system, a blade life greater than 1 week, maintaining a budget of $3,000 per machine, and mechanical and electrical documentation for technicians. Our first focus with this project was to identify the causations of the scissor's increased errors at higher speeds. To do this, the team met with Barde and consultants to learn as much as possible. Even still, unknown factors were present, and the team used high-speed cameras to examine the scissor failing, but the results were not completely telling to the reasoning of the scissor failure. Due to the nature of the lack of insight into the problem itself, the team has taken an experimental approach to the issue. The team will implement multiple changes to the scissor and test their effectiveness and increase speed and longevity to the scissor. A baseline of data will be established through testing in scenarios of reduced independent variables for the most accurate results. The first design for implementation is a blade coating. The blade is made of a tungsten carbide but still experiences wear and chips that lead to increased blade failures. A diamond-like coating or aluminum titanium nitride coating could improve the blade's resistance to wear, decreasing the risk of scissor failures. The coatings will be applied and tested versus uncoated blades to measure the effectiveness. Next, the blade is currently operated by a 2-phase DC motor, while the team is proposing moving to a 5-phase AC motor. This change would greatly increase the torque and speed of the scissor for quicker, more powerful cuts. The challenges we face implementing this solution is the change in power requirements and the implementation of a separate motor driver into an already complex control system. This project has a promising future with the team's experimental approach. Through analysis of multiple changes, the team will determine a best final solution for the Barde Weft scissor.